Good afternoon. This is Steve Wilson at the Illinois State Water Survey. You're here for a webinar on sampling and interpreting results. It's 1 o'clock, so we're going to start. I'm here with Jeremy Overman, who's in our chemistry group, analytical chemistry unit at the State Water Survey. When we get questions today, hopefully between the two of us, we'll be able to answer a few things. I would like to point out that if for some reason we can't answer a question today, we will find an answer and get back to you. And you'll see later on, we've received a few questions that didn't really give us specific information, and I'm going to ask those folks to send us an email with a little more so we can get back to them. So today we're talking about sampling and interpreting results for your private well, and again, this is hosted by the University of Illinois, both the State Water Survey and the Illinois Water Resources Center. The private well class is funded through their Rural Community Assistance Partnership with funding from US EPA through their Office of Groundwater and Drinking Water. So let's get started. So today I'm going to talk a little bit about the private well class. I'm assuming most of you are aware of the class. You found the webinar. It's also, we'll go through some logistics about using GoToWebinar if you haven't done that before. We'll go through the material for today, and then in the end we'll answer some questions both that we've received and we assume will come in from some of the attendees today. So the private well class, if you haven't signed up for the class itself, go to privatewellclass.org, and there is a link right on the front page. You sign up with an email address, your first name and the state you live in or area you're from, and you'll receive one lesson a week for 10 weeks. These webinars are meant to provide specific information that are related in supporting the class. Again, today is about sampling and interpreting results. That's part of the last 2 or 3 lessons. And each of these 6 webinars we plan to do over the next year are topic centered. So today is again about sampling. The next one's about source water protection, and more information's on the website. So here's the front page, that large box with the 1, 2, 3 in it. Just click on that to enroll, and it takes you to a page to sign up. We do have an email address, info@privatewellclass.org. If you have other questions or something comes up that you down the road, there's also a toll-free number that you can contact us. If we're not there, it should be manned during business hours, but you can leave a message and we'll get back to you. So we are recording the webinar today, and it will be available both on our website and on YouTube, I believe. So if what we're hoping is the questions today are more about sampling and interpreting the results, but if you have other questions, feel free to ask. We have had some other questions come in. So we will write everything down and keep track of what we get today, and if we will post them eventually on our website. And we're working on an FAQ that we can put there, so eventually there'll be a lot of answers to a number of different questions that have come in from folks around the country. So this is the webinar page, and you can see there's a mention of the webinar today, 1 p.m. Central Time. The next webinar is August 19th, and it will be on protecting well water from contamination. So it's more about source water protection and the issues surrounding what might cause contamination in your well. Again, there'll be 4 others that we haven't picked a date for yet. So some important points to remember. The whole reason for all of this is private wells aren't regulated. So a community water supply meets regulations. There's maximum contaminant levels they're allowed to have of certain constituents. For a private well owner, except in a few counties where they are regulated in the country, it's completely up to the well owner to maintain, test, and ensure their water supply is safe. And a lot of folks prefer it that way, but some people buy a house in a rural area or that has a well and had no idea that they were responsible for their water supply. So part of this class is to inform the public and make sure that people realize what their responsibilities are. And the thing about well water, I grew up on a well. It can be the best tasting water in the world, but contaminants can be colorless, odorless, and have no taste, which is said here. So you do need to sample regularly to ensure that your well water is safe to drink. One other point, I live on a community water supply now, but I grew up on a well, and I pay about $40 a month for to my water company for our water bill. So that's the cost, and it's spread out over 100,000 residents. for sampling, maintenance, infrastructure, everything to do with ensuring that I have safe water to drink. So there are costs to being a well owner, and you need to put those resources in to ensure your well is maintained and it's the water safe to drink, or that nothing's come up that might lead to that not being the case. And so that's one of the responsibilities you take on as a well owner. So regarding testing and well water quality, there's obviously a lot of questions that come up when it comes to sampling. Here's a list of things we're going to talk about today, at least initially. So where to collect the sample and what to test for. If you ask 10 different health departments around the country what to test for, you'll probably get a slightly different answer from each, and that's because there are different constituents in different areas, different kinds of aquifers. We have sand and gravel aquifers here. There are places out west where wells are in granite, which we have no wells in granite in Illinois. So there's a lot of differences locally based on geology and water availability that might dictate what you sample for. So here's the list we're going to go through today. And again, if you have questions as we go along, there's a place to write those in the GoToWebinar box. And please do so. We have someone monitoring that, and we'll look at those at the end. So where do you collect the sample? One thing that's important to note is that you get a different water quality at different taps. An outside tap that doesn't run through any kind of treatment or comes straight from the well may have one type of water quality versus the water at your kitchen sink, where it's ran through, if it's an older house that has lead pipes, those sorts of things, or if your piping's from before 86, there's lead solder. What you need to do, I know what the water survey does. Whenever someone, a well owner in Illinois, calls and asks about collecting the sample, they ask those questions. Do you have any kind of treatment? Do you have a softener or filter? And they usually collect two sets of samples, one that's before any treatment and one that's, say, at the kitchen sink, where it would have some of those possible differences. And so when you look for a lab, they should give you those detailed instructions and provide that information for you. Okay, so what to test for? As I mentioned, every situation is different. It depends on the depth of your well, the formation the water is coming from, and if there are any known contaminants in an area. Some areas have high arsenic, and it's just a well-known fact it's a naturally occurring contaminant, or some other known contaminant. You need to talk to your county or your state health department, get advice from them on what you should test for. Most of those folks will have a list of things that they would normally want you to test for based on what might be in the area. For instance, Tazewell County, Illinois will always have you test for arsenic because the main aquifer in use in that area is known to be high in arsenic. So that's one way. Also talk to your driller, your neighbors, even co-op extension that work with rural well owners know if there's a contaminant that's naturally occurring. As far as coliform and nitrate, those are considered indicators. Even if they won't necessarily make you sick, they point out issues related to contamination being able to get into your well. And so typically those are what are most recommended annually to test for. And so to answer the question, how often to test, once you've determined the water quality in your well from a more extensive sampling, you should at least test annually for coliform and nitrate because they indicate a pathway to your well. So if something's changed, there's a crack in your casing, there's some surface influence or something in the groundwater that's changed, that will show up that way. Here's an example. In Massachusetts, their Department of Environmental Protection has a website. You type in your address. There's certain areas where they know there's arsenic and uranium, and so you can type in your address if you're in that state, and it will tell you whether or not you should be concerned and maybe test for those two things. Every state's different. You need to talk to your state agency. In Illinois, that would be the Illinois Department of Public Health, and it's DEP in Massachusetts. In Minnesota, it's Department of Health. It just depends on the state, and that information is also available through our website. Here's another example in Rhode Island. They have this map that shows these little pockets of where they are concerned about arsenic, and most of those are related to orchards. And then there's the highlighted area in the middle is actually beryllium, which isn't something we find very often, but in Rhode Island there's a concern, and it is a regulated contaminant for public water supplies. So again, it's just look at what your state might offer or what your county may have available to tell you what things you might be concerned about. What we suggest, and this is based on looking at a number of different state health departments' websites and their information available, these are the constituents we recommend you sample for. If you've never sampled your well, you should do the second set initially to get an idea. If you have, you should sample for copper if you have copper piping. If you have galvanized piping, you should also look for zinc and cadmium. But this gives a health professional and a water quality specialist the information they need to take a look at your water and tell you some of the things you'd want to know, whether your water's hard and what you might be concerned about. And always get advice again from your local or state health department. Contact them first. Tell them you want to collect a sample. Your state regulatory agency should be able to give you a list of all the labs that are accredited. I know that list is also on US EPA's website, and we recommend, as a general rule, you should probably have your sample analyzed by an accredited lab. Here's another, this is wellowner.org. It's the website for well owners that the National Groundwater Association maintains. And here are some other reasons why you might want to test your water. If someone's been sick, if you smell anything different, if something's changed with the color, or anything nearby has changed. There's a whole longer list of reasons why you might want to test your water. I know in northern Illinois, near the Chicago area, road salt starting to become an issue, and water starting to taste salty. And so that's another thing you might be concerned about depending on where you're at. So where to get it analyzed, as I mentioned, every state accredits labs, and also does US EPA for community water supplies. In general, I would say you're better off ensuring you use one of those labs. They've passed a lot of quality controls. I say that knowing the Water Surveys lab is not accredited, and but it's a lab. It's very helpful for well owners. And so we have a program for private well sampling here, and originally it was free until about 2006, I think. And now it's a very small fee that gives well owners information on inorganics and metals to help them understand their water quality better. A good lab will explain everything to you, is used to working with well owners. If they want you to store a sample in ice, or if they want to use a preservative of some kind, they'll provide the bottles for you. And the best way to handle that is to ask questions until you're satisfied. And if the lab is accredited and all those things, they should be able to provide you a pretty standard set of information that makes you feel comfortable about what you're doing. Okay, interpreting results. There are several websites that are available that list information on what sample results mean, so you can get a sense of what your results actually mean. But regardless, if you use one of these sites, and we actually show a drinking water interpretation tool online that's put out by the Penn State Cooperative Extension that will give you the opportunity to type in your results and see some information about what those results mean. Always take your results to your local health department or your state health department and ask them to interpret them for you, just to be safe. There are issues, it might say that, for instance, the arsenic standard is 10 ppb or micrograms per liter for a community water supply. There is no set standard for a private well, but that's kind of the level that most organizations stick to, even for private well water analysis, to determine whether it's safe or unsafe, because that's what the EPA has determined is safe for community water supplies. So get a qualified answer from a health professional. And if you do find something in your well, most of the time it's beneficial to resample and confirm that, just to be sure. Sometimes things get contaminated while collecting the sample, or there may have been some issue in particular. Maybe you didn't flush the line like you were supposed to, or some of those things. And if you have a bacteria hit, then you should have it retested for E. coli, and be sure you're boiling your water until you can chlorinate it or add some other treatment so that it's safe. This is the drinking water interpretation tool I mentioned, and it's available at Penn State Extension. You can type in values in milligrams per liter, and again, that's a big issue. If the lab reports things in micrograms per liter and they tell you you've got 20 micrograms per liter of arsenic, that's 2,000, or that's 0.2 milligram, or 0.02 milligrams per liter. So it matters which units you use. And so, for instance, we typed in 0.1 for the arsenic value, and it says no, the value exceeds the standard, which is 0.01. 10 micrograms is 0.01 milligrams. And so then it tells you, so it's handy just to get an idea of what might be a risk and what might not. And it's something you can use and take to your health department and say, you know, here's what I found. I'm worried about this. What should I do next? So the questions we've received, and now we're going to take questions if we have any from everyone who's participating here. I did want to point out, if you're taking the class, if you're having any trouble, you're not getting a lesson, you should get it once a week at the same time. So if you signed up at 3 o'clock on a Friday, you should get a new email every 3 o'clock on a Friday for 10 weeks that has each lesson in it. If you're not getting those, be sure and email us and let us know. And what I'm planning to do is go through a few of the questions we've gotten, and then if we have any more questions today, we'll go through those at the end. And that's what I have for today, and I appreciate everyone attending. And so the questions, the first one I got was, how often should I shock chlorinate at my deep well? And they also put in there, I believe, should I put it on a monthly schedule? Chlorinating is something that's only to be done when you have a problem with your well. There's a bacteria problem. It's not something that needs to be done regularly. In fact, if you chlorinate your well unnecessarily, it can cause other problems. It can release metals. It can cause damage to the equipment in your well, your pump, and especially at the top of your well where all the seals and those things are. So you should only sample when you've identified a problem, or you should only chlorinate when you've identified a problem. And so you'd want to sample first, and if you have bacteria, then there's a process to chlorinating your well. You should do that once and then test your well again, and it should be safe. It should be clean. And if it keeps reoccurring and you have a problem, then there's a problem with your well itself. Either it's not sealed at the surface, or there's a pathway for contamination to get in your well. You know, we find wells in all kinds of places, feedlots, you know, cattle feedlots, in karst areas, in agricultural areas where the opportunity for bacteria to get into the formation itself may cause continual bacteria problems. And in those cases, I know in karst areas especially, a lot of times you just can't find a safe, you can't put in a safe private well. And in Illinois anyway, in a few of those areas where we have a lot of karst geology, those areas have went to rural water districts where it's a community water supply supplying water to each individual home rather than having individual private wells. But if you do have a recurring problem, you should contact a well professional and seek advice from both, you know, a well professional and probably your health department, because there's something going on. This is from Minnesota Department of Health. It's a really extensive procedure for chlorinating your well, disinfecting your well with chlorine. And I just showed the cover here. It's actually listed under the resources on our website for Lesson 10. If you go to the resources page, and it walks you through step by step, depending on the type of well you have and, you know, the diameter, and so that you're mixing the right amount of chlorine. Again, if you use too much or too little it won't have an effect. Too much, and it can cause damage. And so there's, you know, if you're going to use chlorine bleach, there's a good procedure. And this is probably the most extensive resource that we found, and we think this is the one we're recommending. So what can we do if we have silt in our water? Well, the most common solution would be to add a filter, and that's what I would recommend. So that requires maintenance, and also there's an expense. You need to monitor how much silt you're actually collecting. If, you know, depending on the scale of the problem, it might be possible that you'd want to consider another well or look at some other solution than adding that treatment of a filter. And I don't know any other information about this particular question, and so if the person is on the call today who asked that question. If you give us more info, send us an email. We can look into this further. It depends on where you're at. Is it a common problem in that area? We'd want to talk to someone locally to try to get at what's going on there. So if you would let us know, we can pursue that further. So some other questions we got that aren't necessarily related to sampling or interpreting your results. First one here, I have 80 psi pressure at the well and only 25 psi in the house. What's going on? Basically was the question. I'm not sure if we need more information about this, because your well pressure really doesn't have a lot to do with pressure in your house, assuming you have a pressure tank. Really, the pressure that's coming out that's for your drinking water in your house is based on the pressure in your tank. So your well will kick on when the pressure in the tank gets so low. It may simply be that the setting on your pressure tank is set too low. And again, without more information, it's pretty hard to diagnose what's going on here. But I'm not sure, it's a pressure tank that kind of dictates what's going on in your house. So there is a question about testing for road salt versus saltwater intrusion, and how can we tell the difference? Well, I'm not sure. I've put a request in. I sent an email to the Florida Department of Health, because I'm in Illinois and we don't have a lot of saltwater intrusion issues. And so we certainly have road salt issues, though. And, my initial take on it is that there probably isn't a way to tell the difference, because most salt, road salt, I assume, is coming from a salt mine where that originally was salt water that formed it. So if you want to give us more information about where you're at, again, my job is to not necessarily have all the answers, but to be able to help folks find the answers. And so we can hook you up with someone who's in your area that may be able to tell you those things. As far as guidance on setting my pump because of saltwater intrusion, fresh water sits on top of salt water, but as soon as you start pumping water from an aquifer, you're lowering the pressure gradient or the pressure head. And so that difference in pressure may allow salt water to, intrude into the aquifer. That's what's going on in Florida, especially on the east side. I believe that's where they're having more of an issue. And so, again, this is a question for someone in your area who deals with saltwater intrusion on a regular basis. It does make sense that you need to keep your pump fairly shallow if there's salt water under your fresh water. But it kind of depends on the situation. But I know if you're really close to the ocean, it's likely to, if you're having a problem now, or if you're not having a problem now, you may in the future. And I know this question also asked about climate change and the fact that water levels are supposed to rise in the future. Well, I think if water levels rise 30 feet, a lot of folks are going to have bigger issues than saltwater intrusion, but it depends on your situation and where you're at. So if you provide us a little more information, we can get someone to help you in your area. And the last question we got was, how can I motivate our elected officials and health professionals to protect groundwater from pollution and poaching? This is an unusual question, because what we find is it's just the opposite. Health professionals who are trying to reach out to well owners have a really hard time convincing them that their groundwater might not be safe. Everyone assumes it's safe, and usually it's, as I said, it's the other way around. So I'm interested in your situation. If you would email us and we can correspond, we might be able to deal with that. But especially health professionals, county health department, that's their mission. I find it surprising that they're not trying to protect the groundwater. But we certainly will follow up on your question. So I believe that's all I have. As far as we may have some questions I need to get to here in a second that have come on today. I wanted to mention that there are 5 more webinars. Our webinar page lists those, at least the next one, which is in August, and it's also going to be at night. Someone had asked a question about, are they always going to be during the day, or are some going to be on weekends? And the thing I can mention there is these are being recorded. So if you can't view a webinar or you want to share this with someone else, it will be available as a YouTube video or on our site. I'm not sure if it's both, after the fact. And even the webinars from last year are still up. So with that, I'm going to get out of this PowerPoint presentation and go to our okay, so before we start, we're going to take a 3-minute break here, and if anyone has any more questions, please type them in now, and I'm going to let Jeremy probably answer the first one because he's a chemist and probably has a very good answer for this, so we'll be right back. Go ahead.
This is Jeremy Overman. The first question is, what would be examples of total dissolved solids? Total dissolved solids is a measurement of all of the minerals that are dissolved in the water. So it could be one or a combination of things. Chlorides will show up as part of total dissolved solids. Sulfates, calcium, magnesium, sometimes iron, copper adds to that, but those are very small amounts. So the most common things that would make up total dissolved solids would be chlorides, sulfates, calcium, magnesium.
All right, the next question, what's your favorite online testing resource? If you mean informational resource, there are a lot of sites out there that have information. One of the groups I rely on, and I'm a member of, is the National Groundwater Association. They are kind of the trade association and also the member association for most of the scientists and engineers that deal with, and geologists that deal with groundwater. Another group would probably be, and that's not necessarily testing, but the environmental health professionals group is NEHA, the National Environmental Health Association, and they would be able to provide information as far as they have a lot of information available. Like the National Groundwater Association has wellowner.org. We're obviously a resource for folks, and as far as online testing, if you're talking about getting samples done and that sort of thing, I've not dealt with any of that. I'm fortunate that we have the State Water Survey's Public Service Lab and Analytical Chemistry Unit, and that's who I have do any testing that I do for any well owners or for any projects that we're involved in. So follow-up question for the TDS, I'll let Jeremy answer that.
Sure. The question is organic material included in this category? It depends whether it's dissolved organic matter or not. If it's dissolved, it will show up. If it's not dissolved, we call it suspended solids. So that would not show up in total dissolved solids.
Okay. So the last question, what's the difference between informational testing and certified testing? Well, in some areas, and I'll use Pennsylvania for an example, because of fracking, as an example, well owners are required to use certified testing in order for their samples to be admissible should they have a problem that they there's a cause and there's someone who is a responsible party, someone doing fracking, for instance. Informational testing, doesn't have that legally binding requirement. And I know, at least I believe in Pennsylvania, for certified testing, the lab itself has to come out and collect the sample so that they're sure that it was collected to the standards that meet, rigorous protocols and chain of custody and all of those sorts of things. Whereas informational testing, well, even the work that we do here is informational testing. A well owner can call the State Water Survey, our Public Service Lab. We'll send them a set of bottles with instructions on how to collect the sample and how to ship it back to us and the time frame that it needs to be. And I mean, there's a lot more to it than just that. But in the end, the well owners collected the sample, not a certified lab person or a geologist or whatever. And so many times the samples would have the same results as long as the person collected things according to the right. They let it run for 20 minutes and they did everything the way they were supposed to. Maybe they filtered samples or there's a lot of different things you can do. So just as good is really relative, depending on who collected it. There's a lot of factors there. But certified testing means that it's legally binding. At least that's my understanding. And we don't do that sort of work per se. If a community water supply is having their samples done for compliance with US EPA, then they're using a certified lab and it's certified testing. And that's to ensure a certain set of quality assurance that it's a qualified lab, they know what they're doing, and all those sorts of things. So it's just, it's a safer bet, so to speak. And especially for a private well owner, unless you plan to use it in some legal setting, many times, at least I know our lab, as I said before, isn't certified, and that's just because of EPA requirements and funding issues. But the data we collect and the results of our analysis are just, they come out just the same as if we were to send them to a lab. We follow all the same protocols, all those sorts of things. It's just a lot of the reporting requirements and some of those things that we don't do. So you really have to know about the lab itself and their ability. Different states do different things. I know in Ohio, they actually send samples to those labs in Ohio and that are spiked with certain amounts of constituents, and they all have to come back within a certain percentage or they lose their certification in Ohio. But not every state does that. And so just as good, not always, but it can be. I guess that's my hedged answer. So
another difference is price.
Oh.
Usually
Here you go.
Yeah, another difference is price. Of course, the certified lab is usually quite a bit more expensive than a non-certified lab.
All right. I believe that is our last question. Maybe not. Oh, no, I guess not. The next question is, how far away can a chemical spill affect a water supply? That's completely dependent on the geology and the water flow in the aquifer and those sorts of things. If you're in, and I'll use Illinois as an example, if you're in an area where it's all sandy soil, where the spill has a much better chance of reaching the aquifer and it can travel through the soil much faster, it will dilute it faster, but it certainly can move a lot farther. And versus if you're in an area where it's all really tight clay at the surface, it may take, for instance, right here in where I'm at, there's 200 feet of glacial till on top of the aquifer. And in certain areas, that till, it's all clay and silt and with a little bit of sand in it. It takes water hundreds of thousands of years to even get down to the aquifer. And so it's really relative to your situation, how deep your well is. You could have a spill here that would never reach your well if it's a deep well, for instance, or it may not travel that far even in a shallow aquifer depending on the water movement. In some areas, water can flow up to 100 feet a day or more. In other areas, it may move less than an inch a week or less. So it's very relative. It depends on where you're at in your situation. And the bottom line is the deeper your well and your water supply, your groundwater source, the more protected it is from the surface and the safer it'll be. And that's mentioned in the class materials as well. If you have some folks, because they have maybe a very shallow, sandy aquifer available to them, that maybe the water level is only 10 feet, they may put in a sand point, which isn't a, quote, legal well, at least not in Illinois. And it doesn't have any protection from the surface. Things, from near the surface can go down into the well, or a dug or bored well. Those are much more likely to be contaminated because they're getting water from near the surface. So the next question is, what would be the ideal sample size for testing? I'd let Jeremy take this. I'm not sure. Yeah.
Usually the lab that you're using will tell you what sample size they need. In general, a quart should be sufficient. Some labs might take one sample for chemistry testing and one sample for biological testing. In that case, it might be more than a quart, but in general, a quart should usually be enough. And again, just check with your lab that's going to be doing the tests and find out how much they require.
Go ahead if you want to.
And number 6, do you require sterile bottles for testing, meaning a sealed sample bottle? Usually, again, you should ask the lab. I know at the water survey we send out a bottle kit, and the bottles are acid clean, so they're very clean. We don't, at the water survey, we don't do any biological testing, but you still want to have clean bottles for your chemistry testing.
All right. That's the last question. Again, it may be a little time, but we will have an FAQ up on our site with these questions and actually the questions we had from some of the webinars we did in late last year and questions that we get from our website. So we're trying to build a set of information that will be beneficial to folks. And we just haven't figured out exactly how we want to, if you just list all the questions in order, it's a hodgepodge and it's really hard to filter through and it's very discouraging to try to read through. And so we're trying to create a way to filter on keywords that'll make it easy for folks to find the type of questions they're actually looking for an answer for. So once we get that all set up, it will be on our website. That's all I have, and we appreciate everyone's time. And with that, we are going to close the webinar. Thank you for attending, and if you have any comments or questions, be sure to email us, and we will go on from there. Hope to see you at the next webinar.